presentation, I am going to talk about what you're going to study. So how to identify and include participants in your research. And so in this presentation, I'm mostly going to focus on what sampling looks like in quantitative research, and we'll talk more about qualitative sampling when we get to that portion of the course. And really the answer to who you want to study should come directly from your research questions, right? So you need to figure this all out before you start to collect your data. You shouldn't just go out there with a survey before you understand who your population is and who you're going to sample. All right, so let's just cover some basic terminology related to who's participating in your study. First of all, the population is the group of interest that you want to make conclusions about. So maybe it's all first-year students at ASU, or all students at ASU, or all college students nationally. So oftentimes it's difficult to include all of those people in your study. Just logistically, it's challenging or inefficient to include all of them. So typically quantitative researchers will sample a subset of that larger population that they want to make conclusions about, and then they'll study and include in the study just those participants that have been sampled. But the goal of sampling is to understand the entire population. And so the technical word for that is to make inferences about the population from the information you collect from your sample. So the technical term for whether or not your sample does indeed allow you to make generalizations about the population or inferences about the population is external validity. So essentially that's the idea that your sample is representative of your population on key characteristics that you're interested in studying. So perhaps it's that, your population is 50% female and 50% male, and this sample is also 50% female and 50% male. Or you've sampled your participants from fall 2013, and you're interested in making generalizations about the entire population of college students from 2013, that kind of thing. The idea of external validity is basically that you're pretty confident that your sample is representative of your population. And really, as a reader of research, this is important. When you're reading research, think about the sample that the researchers are including in their study, and whether or not you, in your judgment, think that it does indeed resemble the population. And so that's something that researchers often don't discuss very much in depth in their study, but that's something as a reader to be attentive to. What's the sample, and do you really think that it represents the population that they're trying to make inferences about? So another term that's often thrown around when we're talking about samples and populations is response rate. Essentially, that's just the proportion of your sample that actually ends up participating in your study. So that doesn't speak to the proportion of the sample that comes from the population, but instead response rate is the proportion of the sample that actually ends up saying, okay, I'll participate in your study, I'll return your survey. A final term that I want to define before I start talking about how researchers actually go about sampling is the idea of variability. So that's essentially just the idea that what we study can take on different values. So for example here, most of us have different body masses, right? So body mass is a variable. It varies from person to person. In education, knowledge about a subject matter is a variable. So my knowledge about statistics varies probably from your knowledge about statistics. And in quantitative research, we're interested in studying real variability. So for instance, what degree do students get the same test on a score that intends to measure their mastery of a subject, or their views about academic advising, or whatever. So these things really do vary in real life from person to person, and the goal of quantitative research is to accurately capture that systematic variance, so the actual variability from person to person. However, you need to design your study in a way that will not screw up your ability to correctly measure that variance. And one way that we can screw it up is by sampling wrong, and that's referred to as sampling error. So it's the idea that you're not accurately measuring variability, but you've introduced some sort of design flaw or error in how you're studying that variability that creates sort of the idea of almost false variability. So if your sample does not accurately represent your population, then you can introduce error. And that means that your results won't accurately represent the population. Your inferences about the population will be wrong. And so sampling it's really important to correctly sample and sample in a way that you're able to accurately represent your population and not introduce error in your research. So the best way to avoid sampling error is to use probability sampling techniques. I'm going to explain your different options for probability sampling here using this hypothetical population of college students illustrated here. So first of all, let's say we want to sample 5 cases from our population. So the first way to do it is through simple random sampling, which is really the gold standard of sampling, although it's not always easy to do in practice. But essentially, simple random sampling means everyone in the population has an equal chance of being included. So let's say I'll put everybody's name in a hat, or I'll assign everybody a number, and then I'll use a random number generator and pick those whose numbers are randomly generated. Just pull out 5, whatever. So that's simple random sampling. Everybody has an equal chance of being picked, and then I just randomly pick 5 using whatever method, name in a hat or number generator or something like that. Another probability sampling method is called systematic sampling, and that's useful when you're sampling from lists of names, like a student directory. So you just decide, okay, I'm going to select every whatever number person. So you'll go through your list and pick every maybe 3rd case. That approximates random sampling, but it's simpler in practice, right? So 1, 2, 3, I pick you. 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 1, 2, 3, I pick you, until you have 5 cases, or however many number of people you want to sample. So that's systematic sampling. Another kind of sampling is called stratified sampling. That's when you divide your population into subgroups and take a sample from each subgroup. So, for instance, men and women. Let's say I divide my sample in half, and I decide to pick 3 men and 2 women from the population. You can either do it proportionally, so if, let's say, I will draw my line where the number of men and women in the sample actually reflect the proportion of them in the population, or disproportionate. Let's say I'm especially interested in getting men to respond, so that's why I pick more men than women. And you can always use weights to make your sample match up afterwards, but that's a little bit more complicated for what we're doing here. But essentially, the important thing to know is stratified random sampling is when you divide your population according to some subgroup, and then you randomly sample from each subgroup. So finally, the final probability sampling method is called cluster random sampling. And this is when you select according to clusters of cases rather than individual cases. And it's useful, especially when you want to go interview people, because you can get sets of people who are physically close to each other, like classrooms. So for instance, let's say my population of students is in 4 classrooms. So 1, 2, 3, 4. And I'll just randomly pick my cluster. So let's say I just pick this group, this cluster of students. So then I'll just go to that classroom, and then I'll sample all 4 people from that cluster. And if I wanted 5, maybe I'll just go next door and randomly pick somebody from that cluster too. So that's cluster random sampling. It's especially useful when your population is physically located in different locations. But remember, the important thing is that you should randomly pick your clusters. So don't just say, oh, I'm going to pick all of the clusters that are located in the Farmer Building, because that might mean that you're going to only get, education students, and that won't be representative of your full population of students if you're interested in everybody at ASU. So you have to randomly pick your clusters, but oftentimes that makes it more convenient for you as a researcher to conduct your data collection. Unfortunately, sometimes it's not possible to use probability sampling methods. So you'll have to use what we call non-random techniques. The first one is convenience sampling. So let's say here's a population of people, and I'm interested in picking 5 from there, and I just go outside my office and pick the 5 who are closest to me. That would be convenience sampling, essentially just using people who are easy to obtain, who are really accessible, who are closest to you. Maybe I'll pick everybody who's in my applied inquiry class. That would be the most convenient sample to me. Another non-random technique is called quota. So maybe in our study we want to compare the voice of Latino students to non-Latinos. So I just go to the Latino Student Association and I ask 3 students to participate, and then I pick 2 non-Latino students who are hanging out outside of the office. That would be a quota sampling because I'm interested in getting a certain number of people with certain demographics, and I use a non-random way to do it, right? I went to the Latino Student Association. So that's called quota sampling. Snowball sampling is another method of picking people. So essentially it's getting people with certain characteristics and then asking them to identify others who are similar. So let's say I pick this student who I know is Latina, and she tells me about her friend, and then I go and give that person a survey. And then he tells me about his friend, who then tells me about another, who tells me about another. So that's the idea of snowballing. You get somebody with one characteristic and then ask them to lead me to others who are like them. So it's not random because that person shares something in common with the other person, right? But it's a useful way if you want to find people who have certain characteristics to include in your study. So that's called snowball sampling. All right, so the main takeaway I want you to have from this discussion of sampling techniques is that random sampling methods are better than non-random sampling methods when your goal is to generalize to the population. Essentially, you want to reduce your chance of sampling error, and that happens when you use random techniques, and it really ensures representativeness of the population. However, oftentimes in educational research, it's just not possible to randomly sample. So maybe you want to do a study and you want to make conclusions about all college students, but you know what? You're at Arizona State and your most accessible population is Arizona State students, right? So commonly, educational researchers will nonetheless use non-random methods. But something to know as a consumer of research is that you really should be paying attention to who the sample is that is included in a study that you're reading, and you need to be critical of whether or not you think that that sample accurately represents the population and whether or not you think that the study's conclusions can be applied to a population. So an important question is, how big should your sample be? So if you're going out to conduct a study, how many people or participants should you be sampling? So one certainly good benchmark is to look at the research literature on your topic to find out typical sample sizes. Another thing, and I'll show you one on the next slide, is that you can use a sample size calculator. Typically, if you know that your population is less than 100, you will not sample, and you'll just include everyone. But the larger your population, the more likely you will be to pick a sample and not do what's called a census. So a census is when you include every single one of your population members in your study. But that can be unwieldy and almost impossible when your population is large. Typically, you'll need a larger sample when you know that your population is heterogeneous, right? So if you are interested in studying athletes, perhaps, and you're interested in breaking down your data into categories according to sport, you'll need to probably include a lot of different individuals in your sample in order to represent all of the different sports, maybe, that are at ASU or something like that. So also, if you expect a low response rate, if you know that maybe your athletes, the athletes that you're in your program, don't typically respond very often to surveys, then you should use a larger sample of people so that you can then account for the likelihood that very few of them will respond to your survey or participate in your study. This is a chart that comes from one of those sample size calculators. And here, as you'll see, the big N is your population size, and then the little n is the number of cases you'll need to sample from that population in order to make inferences. So when your population size is smaller, as you'll see, you need to pick a higher proportion of cases from that population. In this chart, they suggest that the minimum number of a population of 100 is 80 cases. I would just go ahead and sample all 100 because the extra 20 really isn't that much more effort. However, when you get over to having a population of 500,000 cases, as you'll see, the minimum number of cases is about 384 in order to technically make inferences about that population. However, my general rule of thumb is the more data, the better. So if you're able to send out your survey or collect your data with minimal amount of effort, typically it's great to send out your survey or involve in your research as many members of the population as possible. But technically, this table shows the number of participants that you need in order to make baseline inferences about your population according to its size. So that gives you a sense of how many cases you should sample to make inferences about a population. Again, this is in quantitative research. All right, and so I just want to note where you should, in an action research report, discuss who your study participants are as well as the setting of your study. And so your action research report will, of course, have an introduction section, and that's where you'll include your research topic, question, problem statement, any theoretical framework you might have, as well as your review of your prior literature. Then in the section that's called the methods section, you will include a discussion of your study participants and setting. And that's where you should write about your sample selection strategy, so what selection strategy you decided to use and why you decided to use it, as well as your response rate, and then also a description of the context where your action research took place. So maybe it's your classroom, your university, whatever, your office. And so it's certainly important not just to describe your sample in terms of who they are and how you pick them, but also the setting where they're located. Oh, right. And then the other two sections of your action research report would be your results and your discussion and implications. But this is, the method section is where you would include a discussion of your sampling strategy. So in our face-to-face class, we'll discuss samples and populations, again, in the context of your action research study. So for those of you who are planning to do a quantitative study, we'll go through some ideas of how you can go about sampling participants and who you're going to be considering to be your population. So make sure to bring to class a copy of your research questions. It doesn't have to be printed, as long as you have an electronic copy or something to reference, so that those of you, all of us, can decide sort of and discuss who thinks they're going to be doing or proposing a quantitative study and who's proposing a qualitative study. And then for those of you who are proposing a quantitative study, we'll get into smaller groups and workshop through different sampling strategies.